The purpose of this lesson is to go over textbook section 12.3, which is inscribed angles. An inscribed angle is an angle whose vertex is on the circle and whose sides are either both chords or one has a tangent line and one is a chord. The following three pictures are pictures of the inscribed angle where both of the sides of the angles are chords. So the angle is on the side of the circle and the sides of the angle are chords in the circle. It's on the edge of the circle and its side lengths are chords, meaning that they cut through the circle. And here's just another variation. All of these are pretty much displaying the same thing. The only difference is kind of showing where the center could be, but these are all inscribed angles. The other option for an inscribed angle is that you can have the angle right on the edge of the circle and one side is a chord, meaning that it goes through, and one side is a tangent. Here's just another picture, pretty much the same thing, where one is the chord and one is a tangent. But these are all referred to as inscribed angles because the vertex is on the circle. It is not in the circle, it is on the circle. The other word that comes along with an inscribed angle is what we refer to as an intercepted arc. This is the arc whose endpoints are on the sides of the inscribed angle. So the angle here itself, whoopsies, this is called the inscribed angle. The intercepted arc is the part of the circle that is being intersected by this angle. So it's this part right here. This is referred to as the intercepted arc. So if we look back at these drawings up here, the intercepted arc is the arc that's kind of intersected by the angle. Here's the intercepted arc, the intercepted arc, intercepted arc, and the intercepted arc. All right, so I know I'm going out of order of your notes, but look down at number 3. It says use the diagram to consider the following. So letter A says, which arc does angle A intercept? So my recommendation is to take your pencil and start with angle A and to trace it outward. So this is the inscribed angle. The intercepted arc is the part of the circle between those two chords. So the arc is a minor arc, it's less than half the circle, and it's going from D to B, and it is an arc, or B to D. Then, let me erase this real quick. It says which angle intercepts arc ABC. So let me get my pen again. And here I have arc A around to B and to C. So if you look at the side lengths that made that arc, it's angle D, because as D extends out past both chords, it's intercepting the circle at arc ABC. So this, which angle intercepts the arc? Angle D, or if you want to use 3 letters, that would be fine too. All right, back up to number 2. The key concept here. The inscribed angle theorem states that the measure of an inscribed angle, the measure of the angle, which here would be angle B, is equal to half the measure of its intercepted arc, which here is arc AC. And I believe that's all that's hiding back here. Yep, so the measure of the angle is always half of the intercepted arc. Now when we did this before, we were dealing with central angles. Oops, I lost my pen. We were dealing with central angles. When the angles at the center of the circle, these two angles and arcs are identical. Here, what we're dealing with now is called the inscribed angle. So instead of the center, or the angle being at the center, the angle is now way back here on the circle. So it's no longer equal in size, it's now half. So let's say this is 60. If it were in the center, the arc would be 60. But now that we're dealing with something called the inscribed angle, that it's pulled backwards to the edge of the circle, this is now a smaller angle, and it's smaller by half. So it says find the value of the variables. this is the inscribed angle, and this is the intercepted arc. So the angle is equal to half of its arc. So we don't know the angle, but we know that half of its arc, half of 116, ends up being 58 degrees. Similarly, so this is a chord and this is a tangent, but because it's on the circle, it is still referred to as an inscribed angle. The intercepted arc is this whole arc right here. So the angle is equal to half of the arc. So here the arc is 246, so that means that the angle is 123 degrees. The other way to think about it too is if the angle is half the arc, then that means that the arc is twice the angle. So you can go either way with it. All right, number 5. So we have A, B, C, and D. So the first one is asking for the measure of arc from B to C. So if B to C is here, then I'm going to extend angle A. Angle A is the inscribed angle, and then B to C is the intercepted arc. And the angle is equal to half, the arc. Well, here it gave me that the angle was 48. So then how big is the arc? Multiply both sides by 2. So that means this arc is going to be 96 degrees. It's asking you to find the measure of angle B. Well, angle B is this one right here. I'm going to extend it out in green. And if you notice that it's intercepting this 110, so the angle is always equal to half the arc. Well, here the arc is 110, so half of it means that this angle is 55. The next one is asking for the measure of angle C. Well, angle C extends this way. So if you notice, it's intercepting this arc, which is AB, which is what it's asking for in part D. In a circle, there are 360 degrees around the entire thing. We know that this green arc up here is 110. We know that this red arc is 96. So in order to find the leftover part of the blue, I'm going to subtract the 110 and the 96 from 360, and it gives me 154. That's giving me the arc, and the angle is always equal to half of the arc length. So if the arc was 154, half of that is going to give me the angle, which is 77. So this was 154, and this was 77. Now regarding showing work, I know a lot of you aren't going to need to write down these little equation type things here. Do it if you need to. A lot of it is that mental math using your calculator, but I do think using colors or even drawing on your diagram is going to be most helpful. All right, a couple more examples. It says find the value of the variables or the numbered angles. So in this first one, it's asking for the measure of x, which is this angle right here, and it's also asking for the measure of this arc, which it's labeling y. X is the angle, y is the arc, so the angle is always equal to half of the arc, but I don't have the measurements of either. If you notice though, the 230 is representative of this blue part of the circle. So then that means the remaining part of the circle would be 230 minus 360. So that means this degrees up here is 130. That's an arc. Oopsies. So half of 130 is going to be this inscribed angle. So half of 130 is 65. So x is 65. And y is 130. For letter B, it's asking for the measurements of x, y, w, x, y, and z. So I'm going to start here with x. I notice that x is an inscribed angle, and the arc that it intersects is this 40. So that means x must be 20. Similarly, if I extend angle y, outward here, I see that the angle that it's, or the arc that it's intersecting is the 70. So that means the angle is half of the arc. So the angle is 35. Looking at angle W, if you were to extend W, in this particular case, it's crossing half the circle, and I know that because it's the diameter. So even though there's no arc measurement here, we know that half of a circle is 180 degrees. So the angle is half of the arc. So if that arc is 180, then that means that this is 90 degrees. And then lastly, angle Z does have this arc out here. So we can take the arcs that we have and subtract from 360. But what I'm going to do is recognize that I'm working in a triangle, that I already have W is 90, and I know that Y is 35. So I'm going to take my calculator, and I'm going to do 180 minus the 90 from angle W minus the 35 from angle Y. So that means Z is going to be 55 degrees. All right, letter C. So what I'm going to do for letter C is similar to how I started the other ones. I'm going to go ahead and pick an angle, and I'm going to pick the 100 and extend it out. So if the angle is 100, that means that the arc is 200. But we know that part of that 200 is made up of 99. So 200 minus 99 is 101. So that gives me the degree for A. I'm going to do the same thing now for this 96. I'm going to extend out the angle that is 96 degrees and recognize that its arc is 96 times 2. So its whole arc, 96 times 2, is 192. But part of this arc is made up of the 99 as well. So when I subtract that 99, I'm ending up that this top part of the arc is 93. One thing that I've noticed now is when I look at this circle, I have 93, 99, 101. The only portion that I don't know is the part of the arc that's labeled B. Well, 360 minus the 93 minus the 99 minus the 101, what's left is 67 degrees. How is this helpful? Well, in this problem, it's asking you for, the measurement of angle C. So I can extend out angle C, and angle C is made up of these two arcs. Those arcs, 101 and 67, those two arcs add up to 168, so the angle is half of that. So that means this angle is 84. You can do the same thing for angle D to extend it out, or recognizing that inside here is a four-sided figure. A four-sided figure is 360 degrees. So 360 minus the angle labeled 84, minus the angle labeled 100, and minus the angle labeled 96 means that D is 80. So I got A to be 101, B to be 67, C to be 84, and D to be 80. And this next one, same idea. I need to find the measure of angle 2. So when I extend it out, angle 2 is this arc right here. I don't have any information. So let's extend out the other angle. Angle 38 extends out here. So if that's the arc, the angle is always equal to half of the arc. So that means 2 times the angle is the arc. So the arc here would be 76. And if I have to get back to this angle 2, it's going to be 38. So that means the 70 was never used. All right, next question. So we have a circle, and inside the circle we have a couple of triangles. It says that the measure of angle 1 equals 70. So I marked it. One thing that I noticed is that we have a radius drawn in two positions. One is drawn here, and one is drawn over here. I know that the relationship between a radius and a tangent is that it's 90 degrees, and what it's created here is an isosceles triangle, redrawn over to the left. The vertex angle is 70, so 180 minus 70, and then when I split the difference between the two angles, they were each 55. I was able to subtract that 55 from the 90 to get the measure of angle 2, angle 3, and angle 4. This was quick. Please let me know if you have any questions. Thank you.